Okay, note card 73, area with respect to y. This is going to build a lot off what we just did with note card 72. We're still finding area between curves, but instead of top minus bottom and integrating with respect to x, we're going to do right minus left and integrate with respect to y. And the reason we're doing right minus left is that same concept as we talked about on note card 72 with top minus bottom. If we integrate right minus left, then it will leave us with the area between the curves. And when we see a visual on number 1, I think you get a much better idea of that. But this is very similar to what we did in note card 72, but just with respect to y. So, let's take a look at number 1, just kind of build off what we already know. This is straight off of an old test as well. Consider the curve y squared equals 4 plus x and chord AB joining points A, negative 4, 0, and B, 0, 2 on the curve. Find the area of the region R enclosed by the curve and chord AB. Okay, so let's get a little graph, a visual of what's going on here. So I'm going to go ahead and try to make a little sketch of this graph. And I have negative 4, 0. That's point A. There's point A. And I have 0, 2 to be point B. And that's a chord. So a chord's a line segment. So I could write the equation of that line, which we'll need in a second. But let's see if we can put in the rest of this first. Y squared equals 4 plus x. So we kind of want to go back to what we learned about conic sections here. Since this is a parabola, but since it is the y's that are squared instead of the x's, this will be opening right or left rather than up or down. And a little analysis of this would let us see that we've got 4 plus x, so we've really shifted 4 to the left here. For example, let's put in a 0 for x. If I put in a 0 for x, I'm going to get y squared equals 4, so y would be positive or negative 2, wouldn't it? So we think about that. Okay, when x is 0, y is positive or negative 2. And when x is negative 4, y squared would be 0, so y is 0. So when x is negative 4, y is 0. So I've got 3 points now. So I can see the shape of that parabola. And I got a little bit probably messy down there on that part. But that's okay because what we're interested in is the area of region R, which is enclosed by the curve and chord AB. So this is all I care about is that region right there. But there's that parabola opening to the right along with chord AB. So we're going to need 2 equations here. And this is going to be one where it's more appropriate to integrate with respect to y. So if I want to integrate with respect to y, then instead of having both equations solve for y, I need them both solve for x. So let's take our parabola, y squared equals 4 plus x, and let's solve that for x. So if I solve that for x, I just have to minus 4 to both sides, and that's a piece of cake. So x equals y squared minus 4. Now, we need to go ahead and write chord AB as an equation. So let's talk about this. I've got point slope formula I could use here. I have 2 points on the curve. I have negative 4, 0 on the line. I have negative 4, 0, and I have 0, 2. So I really could use either one of those points to do this. Why don't we just use the 0 and the negative, or the x negative 4, y 0. So if I use that point, then point slope formula would be y minus 0 equals, now I'm going to need the slope of this line. So when I look at the slope of this line, I say to myself, okay, we've gone up 2 and right 4, this is Algebra 1 skills, up 2 and right 4, so that's 2 over 4, which is 1/2. So the slope is 1/2. And then since we've chosen to use this point, this would be x minus a negative 4, that's x plus 4. Well, if I was just solving this for y, I'd be done. I've got it solved for y, but we want to solve for x. So I'm going to go ahead and distribute the 1/2 in here, and I would have x over 2, or 1/2 x, plus 2. 4 times 1/2 is 2. And I can minus 2 to both sides. I have y minus 2 equals x over 2. And I can get x by itself by timesing everything by 2. And that would be 2y minus 4 if I go ahead and distribute that 2 in. So timesing both sides by 2 just solves that equation for x. And like I said, I could have used the other point. It may have actually been easier maybe to use the other point and still solve for x. Either way, it would take you to this. So now we're going to set up our area, but with respect to y. So our limits are no longer x values, they're y values. So we're not integrating from -4 to 0. Instead, we're going to integrate from 0 to 2, y values. And instead of top minus bottom, we're going to do right minus left. So ask yourself, okay, which function, or they're not both functions, are they? Which curve, this parabola or the chord, which one is farthest to the right of the shaded region? So clearly the chord makes up the right edge of the shaded region, and the parabola makes up the left edge of the shaded region, if you can visualize that. So right minus left means the chord is going to go first. So that's 2y minus 4 minus y squared minus 4, and this is going to be dy. And now, just like we did on the last note card, we're going to use the distributive property here. So I just distribute this -1 into the second parentheses. And just like happened on the last note card, these 4's, -4 and +4, are canceling out. So I'm left with the integral from 0 to 2 of 2y minus y squared dy. And we're going to bump up and divide. So it'd be y squared over 2, and the 2's are going to cancel out. So the antiderivative of 2y is just y squared. Minus, this will be y cubed over 3 when we bump up and divide. And fundamental theorem, we're going to evaluate this from 0 to 2. So antiderivative at the upper limit, 2 squared minus 2 cubed over 3, minus antiderivative at the lower limit is just going to be a big O 0, isn't it? So we end up with 4 minus 2 cubed is 8, so 4 minus 8/3. Well, you can make that into a 4 over 1, and we can butterfly this. Move up a little bit here, make sure I'm still on the screen. So I have 4 over 1 minus 8 over 3. That would be 12 minus 8 over 3 if we butterfly. So we get a final answer. The area between the curves is 4/3. Okay, so that's the only problem on note card 73, area with respect to y. What I'd like you guys to do now is you will get a DOL from the substitute, and you will try these two problems on area between curves. So get you a copy of the DOL for area between curves, and I want you to pause the video, spend some time in your groups doing these two problems, and then when you're ready to check your work, or if you get stuck, you can start the video back up and we will look at the solution. So pause the video, you don't pause it. Pause the video for just a second and try these problems in your groups. Okay, let's see how you did. Number 1, should have gotten an answer of D. And there is the work to lead to that. So you can pause this as needed and match that to your work. And number 2, you should have got an answer of 32/3. A little more work involved here on 2 than 1. So move this up a little bit and let you see all of that. Let me just zoom out just a tad and give you a chance to match that to your work. That was a lot going on there. I do want you to notice one thing. Notice I have OR down here. Look how much more simple this version was. And so let me just talk about that real quick. As you went to do this problem, you may have integrated from -2 to 2, and that's okay. But that was a lot more work. Sometimes you can make use of symmetry. We notice these shaded regions are the exact same amount of area. So instead of integrating from -2 to 2, I could cover up this, integrate from 0 to 2, and just times it by 2. Because we know that whenever 0 is involved in the fundamental theorem, it sure makes the arithmetic a lot easier, doesn't it? So make use of symmetry whenever you can. Okay, your homework will be notes for area. That is problems 1 through 4. And notes on area with respect to y. And this is just 2 problems, number 1 and number 2. Number 2, 1 says without a calculator and with. You'll do the problem without it, and then you'll simply put that integral into the calculator and make sure you get the same answer from the calculator version as you did up here. So 1 and 2. So you have a grand total of 6 problems, and we will put the DOL behind those problems. And that's the lesson for today.